The next presenter, colleague of mine, Justin Bruner from PennDOT. Justin's the section chief in the asset management section of the Bureau of Maintenance in PennDOT Central Office. Justin Bruner.
Hello everybody, my name's Justin. I'm the asset management section chief and asset management engineer here at PennDOT. So we do lots of fun things in asset management, and we're going to eschew the standard light and fluffy stuff and get right into some really fun technical information just to start. So let's talk. What is preservation, right? Is it an activity? Is it a work type? Timing? Is it treatment? Like, what is it really? And where does a structural overlay fit in preservation? It's a good question. Well, the good folks at FHWA have been very kind to us and given us a bridge preservation guide. Pretty happy about that. They note that bridge preservation is actions or strategies to prevent, delay, or reduce deterioration. Good stuff. Restore function, keep bridges in good or fair condition, and extend their service life. I absolutely and totally agree with all of that. Also, in truth, I was one of the people they interviewed for this, so I'm hoping my thoughts carry through here. Here's a list of some of the things they thought about when talking about bridge preservation. If you look at this guide, there's a very long, and I would call it extensive list. There's a bunch of stuff on there. Joint repair, overlays, spot, zone, full painting, right? Crack mitigation, scour countermeasures, and also overlays. So about that overlay. Where does that fit in? What happens if you put an overlay, structural overlay, on a bridge deck? Is it really preservation? Well, I would argue that we have to think about when you do it to consider whether or not it is, in fact, preservation. So it turns out in doing all the data mining that we do in asset management that we've found some really interesting things, right? If you do a structural overlay on a deck early in life, you can get 20 years out of it or more, depending on where it's at, right? Lasts a long time. However, if you do it toward the edge of that yellow box and toward the red, you might only get 8. So, mind you, it costs you the same amount to do that treatment. One time you get 20 years, another time you get 8. So it's better to do it in the green, right? It's a better investment. And really that's what we're driving at here, is better investments. The guide has given us the definition, the treatments, and the timing. So how do we prioritize this? How do we actually execute this plan? So here's a question for you. Here are 3 different bridge decks. Which one would you do first? I mean, if you only had money to do one, which one would you do? If you had money to do them all, which one would you do first? Second, which one would you do sometime in your career? It's an honest question. Some of these things last a long time. Turns out that guide also has a lot of thoughts on how to actually make a preservation program. It's good, right? 11-step process, right? Identify bridges to preserve, create rules, look at performance management, implement projects. All completely realistic standard processes, right? Except, how do we specifically do that? So the guide is a little light on the concept, like fulfilling these concepts, right? Let's talk about a little bit more detail. Like that big red chunk, I think it's number 4 that says rules. I think I spent 4 years on that. Like, no joke, that's a lot. So there's a lot more here that meets the eye, and that's what we're here to talk about. Bridge asset management, right? Sort of the heart of all this stuff, right? Because it takes all the rules that come out that you have to make. It's also one of the requirements of your transportation asset management plan. And it takes all those preservation practices that you want to do, and it helps you to prioritize them in a system, because here in PA we have about 25,400 structures. All of them need some type of work, but we don't have enough money to do work on all of them. So how do you preserve the existing infrastructure as best as you can? And the answer is with an asset management program. Our preservation program is literally our lowest life cycle cost methodology that's utilized in our bridge asset management system. We call BAMS. Its brand name is BridgeCare, right? It's an in-house system. We'll get to that in a second. But that's how we execute our bridge preservation program. First, let's talk about lowest life cycle cost. This is a methodology, not quite a belief, but a methodology, right? How do you get the longest life out of a treatment, right, for the least amount of cost, right? So it comes down to when you do it, when it's eligible, right? What makes sense for it, and we can calculate that. We can quantify that. But that's for a different time. For now, let's just talk lowest life cycle cost. Fundamentally, what that means is a preservation or maintenance first strategy. So when you have the option, do the preservation early, because in the end, over 20 or 50 or 100 or 200 years, it's much more cost effective to do that than let it degrade down to nothing and then rebuild it. We also have utilized the lowest life cycle cost methodology to create our treatment and consequence document, okay? So this is the big thick document that I'm always referencing to my friends inside PennDOT. This is how we select our projects and what we expect to get out of them, right? So if you're doing a latex modified overlay on a fairly good condition bridge, we know about how many years to expect out of it, right? And that way we can calculate the benefit, and we look at the cost benefit. All of our choices are made in cost and benefit. This is a really big document, it has a lot of data to it. We spent a lot of time on it. We also spent a lot of time quantifying the outputs, verifying, validating what actually happens in there. And this is actually a slide from a while ago, but know that in reality, in a given run from our system, there's about 25,000 structures. We look at it 12 years. It's a lot of years, it's a lot of structures. And in the end, at the very end, we look at that and we look at the bridges that actually fell outside of our treatment and consequence window. We only get about 8. So as far as I'm concerned, I call that a success. So this is our deterioration modeling document. We use this, the deterioration modeling, in conjunction with treatment and consequence in our bridge asset management system. This is how we project how something will deteriorate into the future. That's actually very important. It's also very complicated. It's difficult to figure out how something will behave in the future because you don't necessarily know all the things that have happened to it. We try to work in families. One of the most interesting things we found statistically is that bridges behave differently per district in the DOT, far and above anything else. We've checked material of construction, we've checked weather, anything, right? Turns out that just the physical location itself has the biggest influence on deterioration. We've also noticed an enormous amount of interesting things inside the data itself, right? So we can look at national data and compare it to our own data, and we all have the same problems, right? There's a fair amount of scatter. See that big portion in the front there, right? That's scatter. It's skewing our graph one way. So how do we deal with that? And we feel as if we have come up with the best way to deal with that scatter, and that's a mathematical model we don't need to get into, but the point being is that we feel as if we've answered this relatively well. So there are all the components that go into that bridge asset management system. At PennDOT, the BAM system is Bridge Care. Bridge Care is a homegrown system. We have a long legacy of making our own stuff, okay? From the stuff that we keep our records in, which is BMS2, to our construction management system, to our planning system, they're all homegrown. So it's very logical for us as a DOT to continue down this path. We have the expertise in-house. We have the technical ability, so that's what we've done. We've partnered with an engineering firm to work through and create our own bridge asset management system that we're pretty proud of. Here's just a quick snapshot of what we have. I know you can't read across the top, but it's important to note what these tabs are because they really tell you the power of the system, right, to give us our best preservation program. We can look at different analysis methods. We can look at different treatments. We can custom tailor our budgets, right? So if you can faithfully replicate your spending process, you can faithfully replicate a lot of other things inside. So we're faithfully replicating our spending process as best as we can. We can look at targets and deficiencies, and most importantly, we can upload a list of committed structures, so things you know you're going to work on into the future, so that you can fill in that extra spot on your STIP or TIP here in PennDOT with better selections that are made automatically for you and optimized. So here is just a very small snapshot of the output. Some of our outputs can get up to 50 megs, which is a really big file. They're all Excel based, and it just gives you reams and reams of data about the bridges that you're analyzing. The point for me to show you this is that we offer a recommended treatment per structure per year for every year of that analysis. It's kind of a big deal. And believe it or not, most of the time, you don't get a treatment because we just don't have the money, right? Fundamentally, we are, by my definition, underfunded. That's something we can talk to Mike about if he was here, but we need more cash. Now, the biggest and best outcome of our homegrown bridge asset management system is that we can change the way we manage our structures. So previously, and I should say currently, we've had a long history of managing number of pour structures or number of pour delivered. There's been times where we looked at the pour on rate, and all looking at poor. Well, that's actually a past tense, right? So you're looking backwards, not forwards. And what we need to do is get away from those lagging metrics and get to more leading metrics, actual KPIs. So how do you get to that, right? The idea is that we can actually start to look now at monitoring how we invest our money in different pools of money, so preservation, rehabilitation, replacement, maintenance, rather than looking at specifically at those individual numbers of bridges, and then using bridge care to help manage and select projects within those buckets of money. That's really exciting and should provide for better investments into the future. Hopefully we can get to that here soon. We've talked about bridge care and its ability to help and assist with prioritization of projects, but it can also offer us business intelligence, right? So there's a pretty sophisticated multi-objective decision analysis engine in the background. So it can do a lot more things. So let's talk about that. So first, we can compare outputs, right? We can say, hey, let's look at lowest life cycle cost and compare that to a worst first scenario where you're only chasing like the number of poor bridges. And in the short term, we can show and prove that if you continue to chase just poor, your overall conditions get worse quicker. Second, we can then use this technology to look at where we need to be from a performance standpoint, okay? So let's say as the DOT, we want to stay less than 10% poor on the NHS because that's what the feds would like us to be. Okay, I'm not super happy about the whole concept of measuring poor, but I do want to be compliant. So how do we look at that? How do we use this tool to look at that? Well, we use that, remember that button before, we're going to use those targets. And I say, okay, I don't want to be any more than 10% poor. What's it take? This graph represents that scenario, and that scenario is about twice what we normally spend on structures. So really what we can do is actually put a number to the spending we need to be to keep in a particular level. That's super awesome. So third, we can use this multi-objective tech to actually look at the entire programming process. So many of us, all different states DOTs, we all have some type of asset management system, whether it's bridge and pavement individually or together, doesn't matter. What they're fundamentally doing is providing recommended treatment per asset, right? So this bridge needs an overlay, this roadway needs reconstructed, okay? That's what those systems are telling you. However, as a DOT, you're not putting out a contract to rehabilitate this bridge or replace this roadway, right? You're going to combine it together. You're going to go from point A to point B and do all the assets in between, whatever it is they need. And what we finally found that we can do is that we can use the back end of our system to actually start to automate that. So here at PennDOT, we call it a TIP. Most other people call it a STIP. But fundamentally, that 12-year or 10-year plan out into the future, we can start to populate using this MODA engine. So that's pretty exciting for us. This is a fairly new concept for most DOTs to be able to get into this sort of depth and tech. We're calling that Project Builder, and Project Builder effectively sits on top of our bridge asset management and our pavement asset management, reads off those recommended treatments, and then actually starts to make projects. Very exciting. The difference being is that Project Builder is a little different and is not recommending a specific treatment, is actually trying to build a project, and it's taking many other things into account to build those. So if we want to talk about travel time, mobility, condition, right? It can actually add all those things together into a decision process and give you the same prioritized outputs as the BAMS and PAMS systems. It's pretty exciting stuff. We do this by effectively monetizing all those different choices and then putting it together and allowing the person to figure out how they want it to happen and look at the outcomes, right? So safety may be really important, right? And it may cost you 3 times what you're planning to budget on it, but if you can save effectively 10 lives out of it, that's a project that probably should take priority over, say, another rehabilitation that may not save anything. And that's how we can, the beauty of this system is that sort of decision making can now be made at the programming level and the whole way up the top out to bid. Just as a quick FYI, BAMS and PAMS, they exist. We have some users in the room, some real fans on the front. Everything's awesome. We're looking to do new releases in the 3rd quarter of this year to make them Project Builder compliant. And when we do that, this is all open source tech, so whoever wants to have a copy of this, they're more than welcome. With that new release, we're looking to include executable files so you can actually download that and use it for yourself. We expect to launch Project Builder I'm hoping December of this year that we'll actually have it out online, available for internal use. Hopefully we can get, it's a lot to make that happen, but it's definitely aspirational. But yeah, I expect more on that, more utilization probably in the first quarter of 2023. I'll take any questions. So the question was, how do we allocate funding within the system? Actually not. So the funding is basically a pool of money that you're eligible to use out of, right? And then every treatment for every bridge is calculated. And then the cost benefit for every eligible treatment is calculated. Then it's ranked the highest cost benefit to the lowest cost benefit. Then we apply some risk factors, and effectively then you get fundamentally a list that you work off of top to bottom, that you fund everything you can until you run out of money. There are a lot more variables to it than that, because each bucket of money can have its own set of rules to faithfully emulate the business process, but in essence, that's the simplest way of looking at it. Correct, very much bottom up. We are looking at individual bridge specific every time, which is a dramatic departure from most commercial offerings. Anybody else? Yes, sir. So the question is, how do I validate my decision process? So there's multiple facets to that. One of which would be deterioration. So we can look back year to year and look at year change. So in fact, we do run a 10-year rolling average deterioration that we go through and recheck everything, rerun everything to ensure everything is working correctly. Because our deterioration can and does change because we're changing our overall business model. So before we didn't do a lot of preservation, now we're doing a lot of preservation. Our bridges will last longer because of it. So our deterioration annually is adjusted for that. In terms of the decision criteria, so which bridges are or are not selected, we try to validate that manually, but it's really hard to validate that programmatically, because not every decision that comes out of an automated system is actually going to get programmed and built, because there could be other really good reasons to do something different other than what the system says. So the system could say, this bridge is a spectacular candidate for preservation. Turns out that bridge gets replaced. Well, obviously that's not lowest life cycle cost. Why did that happen? Well, what we didn't know, and what there's no data field for, is they're going to put a new warehouse in over here and the bridge needed raised and moved. I don't know that. So it's a much more difficult time to validate those type of decisions, but we do try. The question is, do I take user costs into the account? So road user cost, that kind of thing? Right, okay. So not in a bridge or pavement specific software, so not in BAMs or PAMs, but that is something we're looking to build literally right now in our project builder software. So that can be a variable that which you can utilize for weighting on your overall decision. Thanks, everybody.
Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.